Have you ever wondered if the universe in its vast expanse has an edge? This question has puzzled the greatest minds of humanity for centuries. Some may argue that the universe, like a planet, must have a boundary, a definitive endpoint. But the nature of the universe is not so simple. Its expanse seems infinite, challenging our conventional understanding of space. When we think of space, we often imagine it as a three-dimensional setting with a start and an endpoint. Yet the universe defies this simplistic understanding. It's not a flat plane or a sphere with an edge to reach. Instead, it's a vast, seemingly endless expanse, stretching out in every direction. It's like a cosmic ocean with no shore in sight. Yet, in this infinite sea, we have what's known as the observable universe. It's the portion of the universe we can see from Earth, limited by the speed of light. You see, light takes time to travel. When we gaze at the stars, we are actually looking back in time. The starlight we see today may have started its journey millions, even billions of years ago. So, the further we look, the further back in time we see. But here's the kicker. The universe is approximately 13.8 billion years old. That means we can only see objects as far away as light has been able to travel in that time. Beyond that, we're effectively blind. Our view is limited by the cosmic horizon, a sort of edge to our vision of the universe. So does the universe have an edge? It's a question that leads us into a realm of cosmology where our understanding is continually challenged and expanded. And while we may not have a definitive answer yet, we do know this. Our comprehension of the universe is limited by what we can observe. We can only perceive a fraction of this cosmic expanse. So, while we can't physically see an edge, our understanding of the universe does have its boundaries. But here's another way to think about it. Can you find the edge of a sphere? Imagine holding a globe in your hands. You can run your fingers over it, spin it around, but you'll never find an edge. You'll eventually circle back to where you started because a globe, much like our Earth, is a shape without an edge. It's a closed surface, finite but boundless. Now let's take a leap of imagination and apply this concept to the universe. Mind-boggling, isn't it? But it's one of the intriguing theories that scientists have proposed about the shape of the universe. They suggest that the universe might be similar to a sphere, a shape that has a finite amount of space but no discernible edge. In this model, known as a closed, curved universe, you could theoretically start at one point, travel in a straight line, and eventually return to your starting point, much like circling the globe. It's a bit like being on an immense cosmic merry-go-round where there's no end or beginning, no corners or edges to stumble upon, just an endless, looping journey through space and time. This perspective also introduces the fascinating concept of space-time curvature. General relativity, Einstein's theory of gravity, tells us that mass and energy can warp space-time, sort of like a bowling ball resting on a trampoline. The more massive the object, the more space-time curves around it. In a closed, curved universe, the overall density of matter and energy would be just right to curve space-time back onto itself, creating this looping, edgeless universe. But remember, this is just one theory amidst a sea of possibilities. The universe could be flat, infinite, or even take on a shape that our human minds can't yet comprehend. We're still in the early days of understanding the universe's true nature. So, in that sense, the universe might not have an edge but rather loops back on itself. Now, let's dive into the mysterious world of dark energy. Dark energy is one of those elusive concepts in the world of astrophysics that has been perplexing scientists for decades. It's a form of energy that permeates all of space, and its existence was first proposed to explain a startling discovery. Our universe is not only expanding, but it's doing so at an accelerating rate. Let's imagine the universe as a loaf of raisin bread dough. As the dough rises or expands, the raisins move farther and farther away from each other. This is similar to how galaxies are moving away from each other in our universe. But what's causing this dough to rise? What's driving the galaxies apart? The answer, scientists suggest, is dark energy. Dark energy is thought to make up around 70% of the universe's total energy content. It's like an unseen force field spread throughout the universe, pushing galaxies apart and causing the universe to expand at an ever-increasing rate. Now, what does this have to do with the edge of the universe? Well, if we think of the universe as a balloon being inflated, the edge of the universe might be the skin of the balloon. As the balloon inflates, or as the universe expands, new space is being created. Beyond the edge of the balloon or the universe, there is no space, or at least not yet. This expansion driven by dark energy could imply an ever-growing edge to the universe. It's like an artist constantly adding canvas to a painting. The painting, or our universe, is continuously growing, creating new space. However, it's important to remember that these ideas, while based on our current understanding and observations, are still theories. The universe is vast and complex, and there's much we still don't know. Dark energy is a mysterious and intriguing piece of this cosmic puzzle. This means that the universe could be growing an edge, so to speak, as it expands. But what if our universe isn't the only one? This question leads us to a fascinating concept, the multiverse theory. This theory proposes that our universe is not unique, but one of a potentially infinite number of universes, each existing independently, each with their own laws, dimensions, and yes, their own edges. Let's take a moment to fathom this. Imagine a bubble bath, with each bubble representing a separate universe. These universes, or bubbles, float in a higher dimension of space, an expanse known as the multiverse. Like bubbles, each universe has its own boundary, its own edge, separating it from the rest of the multiverse. In some of these universes, the laws of physics might be similar to ours, allowing for the existence of galaxies, stars, and planets. In others, the laws could be so different that they are entirely unrecognizable to us. Each universe, according to the multiverse theory, began with its own Big Bang and will end with its own fate. Now let's bring this concept back to our original question. Does the universe have an edge? If we subscribe to the multiverse theory, the answer could be yes. Our universe might indeed have an edge, a boundary that separates it from the other universes in the multiverse. But this edge would not be an edge in the traditional sense. There wouldn't be a sign reading, "You are now leaving the universe. Please drive safely." Instead, the edge of our universe would be more of a transition point, where the laws of our universe give way to the laws of another. This concept is, of course, purely theoretical. We have yet to find any concrete evidence of other universes, let alone their edges. But the multiverse theory opens up a whole new realm of possibilities to consider, a new perspective on our place in the cosmos. In the realm of the multiverse, our universe might indeed have an edge, but it's just one of countless others. So, does the universe have an edge? The answer isn't as straightforward as you might think. We've journeyed through the complexities of the cosmos, exploring the observable universe, that vast cosmic sphere we can peer into from our tiny blue dot. We've pondered the idea of a closed, curved universe where traveling in a straight line could, in theory, lead us back to our starting point. We've delved into the role of dark energy, an elusive force pushing galaxies apart and driving the universe's relentless expansion, and finally, we've considered the multiverse theory, the idea that our universe might be one of countless others, each with its own laws of physics. These are not simple concepts. They challenge our understanding of reality, of space and time. They invite us to ask questions, to wonder, to seek. In the end, our understanding of the universe's edge is as boundless and mysterious as the universe itself.